Okay, question number 5 with a graph of, so this is GOF and this is fog. So GOF of X will be F inside of G, so that will be sine of 2 sine X, whereas fog of X will be G inside of F, so sine of sine 2x. Okay, so the question initially asks, for the graph of GOF has two local maximas. Okay, so there's that one and there's that one. Only one of them, there's part, so we're looking for that particular value. Find the coordinates of this local maxima. Okay, so if I was to GOF, so sine, see if I can get it in a nice form straight from the calculator, sine of X, close bracket twice. And if I open up my graphing window and I memory initial, okay, and I pick that up and drag and drop, and I look at that area there, which is what they've got there. I'm looking for analysis, G-solve max, and the max, one decimal place, fantastic. So 0.9 and 1 is the coordinate of the maximum point. What's the range of GOF? So the maximum is 1, and since it is the sine, the maximum will be plus or minus 1. So just double check that. That maximum is also 1, and there's that maximum, but I'm not interested in that maximum. The minimum is going to be -1, -1, -1, -1. Beautiful. So I think the range of this is going to be state the range for 0 to 2 pi, -1 to 1. Now double check, see if it's an answer about the particular domain, 2 pi, okay. And I certainly go from -1 to +1, so that's correct. Over the page, state the derivative of fog. So fog is the other one. So fog is the sine of 2x. So that one's got a different domain. And I'm interested in its derivative, is that correct? Yep. So if I take that and take its derivative, and I can write that to equal, so f of g of x derivative is equal to 2 cos of sine of 2x cos of 2x. Show that the equation, this, has no real solutions. Cos of sine of 2x equals 0. Okay. The range of sine of 2x is -1 to 1. But cos of theta equals 0, theta's got to equal pi on 2, and pi on 2 is bigger than 1, therefore no solution, because the maximum is the cos of 1 degree, radian. Okay. Find the x values of the stationary points of fog, and fog is this derivative here. So if I take this and I set that equal to 0, and I put in my restriction given x goes from 0 to pi, and take all of that and solve for x. And do that in standard. Okay, x equals pi on 4, 3 pi on 4, 5 pi on 4, 7 pi on 4. Find the range of fog. The sine of 2x. So the only things coming out of here are -1, 2, 1, which means the minimum value that this can be is the sine of -1, and the largest value that can come out is the sine of 1, where these are radians. So I'm going to say it's the negative sine of 1 radian up to the positive sine of 1 radian. It's going to be the range. So if I graph both of these together and have a little look and see what's happening, and I want to graph this one here as well. So this area and this area is the same, and the intersection points are there and there. Okay, so the area is going to be two lots of the integral from 0 to pi. Top curve is the blue one, and the blue one is off. So g of f of x minus the bottom curve, which is fog, dx. And state that area. 1 mark. Okay, so I'm just going to use my calculator. G solve integral intersection. I'm going to accept the first one and accept the last one. And that's going to give me an area equals 4.96911, or area equals 4.97 square units. And in D, find, I might just pause that